Okay, in this chapter, we want to calculate the numbers with other bases instead of decimals. Right? So let's look at the first case. We want to add these two numbers, but these numbers are given with base 8. And of course, one of the way to calculate is you just convert any given numbers with the different bases to decimal first and calculate it and change back to the original base. Okay, but that is one way, but it takes longer. So let's just practice for the calculation with that given base only, right? So let's just start with addition. So 562 with base 8, of course, and 735 with base 8. So let's just add them. We just use similar method. So look at here. What you are doing is just same as regular operation, like addition, subtraction, multiplication, as in decimal notation. So having different base means only the place values are different, but all the other parts are exactly the same, right? Because everything is just right now positional number system, right? So the position has different values. That's the only difference. And after that, everything is exactly the same. So let's look at this case. Keep this one in your mind. Base is 8, so we cannot accept 8, 9, or something like that, right? So when you add these first two unit values, 2, 5 is 7, so 7 is less than 8, so it's acceptable. Next one, 6 plus 3 is 9. In traditional case, in decimal, we accept 9, but there is no 9 in this word, right, with base 8. So we have to convert this 9 to that number, right? Okay. So keep this one in your mind. The given numbers are on base 8 system, and when you add this, we add them in decimal concept, right? There are 6 bins and another 3 bins. What is the total number of these bins? We know it's 9, which means that 9 is decimal in the system, but we need to change that onto base 8. Okay, so 9 is same as what? In the previous chapter, you have to take the division, right? Then the quotient is 1, which is less than 8, so we accept it, and remainder is 1. You have to write down backward. It's the same right now, but anyway, so 9 with base 10 is same as 11 with base 8. So in this case, the result is 11. Then in traditional decimal addition, whenever you got 12, 13, then you just put 1 to the left side, right? So it's going to be 1 carry over to that, and 1 is here, okay? The meaning is, whenever you got the quotient, it must be placed 1 left side, right? And the only remainder should be there, okay? Then in the next one, we have to add all these 3 values together. Then it becomes 13, right? So even in the decimal notation, you have to put 1 and 3 like that, right? But now, be careful, 13 is a decimal, so we have to change that one to base 8. So we have 1, 8, and 5 left over. So it should be 1 and 5. Okay, so don't forget to put 8, and that should be the sum of those two. So when you write down, it should be 562 with base 8 plus 735 with base 8, or if you want to make sure, like that, the result is 1517 with base 8. Now how about subtraction? It's exactly the same style. We want to subtract this number from this one. So it's going to be C009D and subtract 3A0F. Okay. The base is 16. So we need some kind of cheating paper, right? So 0 through 9, all we needed, and if it's A means 10, B, C, D, E, F. So 11, 12, 13, 14, 15. So when you do this, D minus F is same as 13 minus 15. We cannot do that, right? Because this number is bigger than 13. So we have to kind of borrow from the one left side. So if we borrow 10, then it changes to 8, right? Now 10 is not really 10 because the place value is 16 because base is 16. So instead of 10, we have to think is 16 plus 13. That's what we have. And subtracting 15, right? So altogether, we actually doing 29 minus 15, which is 14. So 14 is the answer, but instead of 14, we have to put E. Okay? Next one is just 8 minus 0, so it's 8. Now 0 minus A, we cannot do that, so we want to borrow from here. There's nothing in there, so we have to borrow from there. So if you borrow 1 from C, then C becomes B, right? Subtracting that. Then when you move 10, it becomes 10 in this position, which is actually 16, right? At that position. But we need to borrow 1 to the right, so the 16 changed to 15, and it changed to 16. Okay? So 16 minus A is 10. So it becomes 6 here. Next one is 15 minus 3. So it's going to be 12, but 12 is same as C. And B minus 0 is just B. So the result must be like that. Okay? So in typical way, we did like this, right? Whenever you borrow it, it changed to actually unit value, right? The base value. So not 100, right? Like that. Okay. Careful. So that's what we did over here. Okay. The last one is multiplication. It's exactly the same. So for easier calculation, I gave base 5, but if it's base 36, or the same thing, just you need some kind of cheating paper like A through Z and comparing numbers, right? But other than that, it's just like this. So with base 5, so kind of 0 through 4 is the only symbols we could use, right? So let's multiply them. Then it's 4, 3, 2, no problem. But the next one is 4 times 4 is 16. But it's way more than 5, so we have to divide that by 5, and the remainder is 1, which means 16 as a decimal notation, decimal number, is same as 31 with base 5. So when you multiply 4 and 4, we need 31, right? So we have to put 3 and 1, right? Now, 3 times 4 is 12. So when you divide by 2, it's 22. So 22, listen carefully, it's 22 with base 5. So we want to write down 2 and 2. But we have to adding that 3 with 2, right? Which becomes 5, which becomes 10, right? In base 5. So eventually, because of this extra 3 there, this side has 3 at 0. And we have one more carryover, which makes 3 over there. And the last multiplication, 2 times 4 is 8. Divided by 3 means 1, and remainder 3, so it's going to be 13. But that 13 must be added by 3 again, right? So it becomes 16. Okay. So you have to do this one again, which is 31. So it becomes 31. Okay. So altogether, it's going to be 4, 4, 2, 1, 3 with base 5. Of course, when you do this, some cases you might have 5 or greater number by addition, then you have to carry over that again, right? But it's exactly the same as what you have done in decimal notation. So just to practice a little bit, right? then it's going to be no problem.